Hi student, welcome in our today's session. Today we start our next point in our chapter application of derivative, that is increasing and decreasing functions. So first we see what is meant by increasing functions, or it is also called as a monotonically increasing functions. A function f of x is said to be increasing or monotonically increasing on its domain or on its interval if its derivative is positive in that given interval. A function f of x is said to be an increasing function. It's said to be an increasing function on an interval if f dash of x is greater than 0. If the derivative of function is positive, then the function is said to be increasing function. Now second one, that is a decreasing function. When function is said to be decreasing. Next one is decreasing functions. When function is said to be decreasing, same here. Function is said to be an increasing if its derivative, that means if f dash of x is positive, then function is increasing. Now if function is decreasing, that means when the derivative of function which is less than 0, when the derivative of function is less than 0, then function is said to be decreasing function. And if we take the derivative of function and if it is positive, then the function is increasing. If derivative is negative, then the derivative function is said to be a decreasing function. Now the next point is that local maxima and minima. So first we find we have to find the maxima and minima by using two tests. In book we have given two tests, that is first derivative test and the second derivative test. But the problem is solved by using second derivative test always. So what is first derivative test? A function f of x said to be a maxima of function y is equal to f of x is said to be a maximum if first condition f dash of c is equal to 0. Maximum is said to be maximum and x is equal to c, where c is any point when the derivative at that point is 0. Second one, f dash of c minus h greater than 0, where h is very small integer. Next, third one condition is there, f dash of c plus h is less than 0. That means if our function satisfies these three conditions, then we say that the function f of x is said to be a maxima, or it has a maxima at x is equal to c. And the next one, that is the function y is equal to f of x is said to be a minimum. It's said to be minimum if, when, again if it satisfies again three conditions, at x is equal to same again f dash of c 0. Second one, f dash of c minus h less than 0. And the third condition is what? That is f dash of c plus h is greater than 0. If the function satisfies these three conditions at x is equal to c, then the function has a minima. And if the function satisfies the first three conditions at x is equal to c, then function have a local maxima, and for second condition functions have a local minima. The second condition, when the test first fails, if f dash of c is equal to 0 and f dash of c minus h is greater than 0 and f dash of c plus h is also greater than 0, or f dash of c 0, next one f dash of c minus h less than 0 and f dash of c plus h is less than 0. If function satisfies these three conditions, then the first derivative test fails and the point x is equal to c is called point of inflection. The point C is called as point of inflection if it does not satisfy the condition of local maximum or the condition of local minima. Then the function is said to be at x is equal to c. This point is called as a point of inflection. But we don't solve the examples by finding the maxima or minima by using the first step. We always solve these type of examples, local maxima or local minima, by using the second derivative test. So first we see what is the second derivative test. Second derivative test. So first, y is equal to f of x is said to be maximum value, or it's said to be maximum at x is equal to c if f dash of c is equal to 0 and the most important condition, f double dash of c is less than 0. Remember that what is second derivative test? First we have to find its first derivative, then comparing to 0, then we will get the two possible values or three possible values of our x, or that is whatever or point that is c. Then we have to use the point or the value which we get if we comparing this is equal to 0, then we will get the values of x, that is called as c. Then put the values of the c or the x in the double derivative of our function, and if the value of this double derivative at a given point is less than 0, म्हणजे जर तुमची ती व्हॅल्यू निगेटिव्ह येत असेल, then the function attains maximum at a point c, but which is not a maximum value. At that point it attains maximum. Now the second, y is equal to f of x is said to be minimum, is said to be minimum at x is equal to c, again same condition, if f dash of c is equal to 0 and f double dash of c is greater than 0. Again remember that, which is very important question in board exam. We have to ask the question for 4 marks. Find the local maxima and local minima. Also find the maximum value or minimum value for the following functions. So we don't using this test. We solve the example by using our second derivative test, which is a very easy test. So first, if we have given any function, then we have to take its first derivative, then compare its derivative equal to 0. Then we will get the value of our function, that is x. Consider this as a c. Then take the derivative. Again we have to take the second derivative of our function. Now use the value of c which we get in our second derivative, and if our second derivative is positive, if it is positive, then the point c attains local minima. If the double derivative is positive at a given point, then the point c function attains minimum value at x is equal to c, but which is not actual minimum value, and we have to find the minimum value. How is it? We have to put the x is equal to c, that means whatever the point we have get, to use the point in our function f of x, and which is this value obtained, this is our minimum value. But the point which is not our minimum or maximum value, at that point we get the function is maximum or it is minimum. Now we are going to start to solve our second last exercise, that is exercise number 2.4. Now remember that the things, that is approximations, Rolle's theorem, Lagrange's mean value theorem, these are not for syllabus, but this the question will be asked of the topics, that is on the topics of Rolle's theorem, Lagrange's theorem, and also approximation in CET or in your JEE exams. This is reduced only for our board exam, but the question will ask on this topic, so you should try to do study for the topics. Next, exercise 2.4. First, question number 1. Check whether the following functions are increasing or decreasing. Test whether the following functions are increasing or decreasing. Whether the following functions are increasing or it may be decreasing. So see first question, that is first function is given here. F of x is equal to x cube minus 6x square plus 12x minus 16, where the all x belongs to the set of real numbers. So this is our given function. We have to check whether the function is increasing or decreasing. In first point, we see when function is increasing, if its derivative is positive, then the function is increasing, and if its derivative is negative, then the function is decreasing. That means if we have to identify the decreasing or increasing function, so first we have to differentiate the function. So differentiate with respect to x. Then what is the derivative? F dash of x, derivative of x cube 3x square minus derivative of 6x square 12x plus derivative of 12x is 12 and minus 16 is 0. Now take 3 common from this. 3, here 3x square, not x cube. Hence it is x square minus 3 4s are 12 and again 4. Since the 3 as it is, now x square minus 4x plus 4, this is the expansion of x minus 2 bracket square. This is an expansion of x minus 2 bracket square. Now see here, this is a square of x minus 2. This term is always positive except x is equal to 2. The square of every real number is always positive because the set of real numbers. Since here x minus 2 square is always positive. It's always positive, but main condition is not x not equal to 2, and therefore if x minus 2 is always greater than equal to 0, since the 3 into 3 is positive here, therefore 3 into x minus 2 greater than equal to 0. What is this? Is a derivative, therefore f dash of x greater than equal to 0. Here we get the derivative is positive since the given function f of x is increasing, therefore given function is increasing function. If the derivative of function is positive, then it is considered as a function is increasing, or it is also said says that the function is monotonically increasing. Now see the next question. F of x is equal to 2 minus 3x minus x cube. Question second. F of x is equal to 2 minus 3x plus 3x square minus x cube for all x belongs to R. Again we have to give the set of whole real numbers and we have to check whether this function is increasing or this function is decreasing. So again take the derivative. Derivative of 2 is 0 since it is constant. Minus 3x, derivative is minus 3. Derivative of plus 3x square, that is 6x. And here the derivative is x cube, that is minus 3x square. Minus 3 plus 6x minus 3x square. Again from this we take 3 common here, but minus 3 common. Since here it becomes plus 1, that is minus 2x, and here again it is plus x square. Minus 3 into x square minus 2x plus 1. Write the minus sign as it is. Now the x square minus 2x plus 1, which is a square of x minus 1 bracket square, since the middle sign is negative. Now see here, the square of this x minus 1 square is always greater than equal to 0 for x not equal to 1. But here the minus sign, outside minus sign, since if the term is positive because of this minus sign, it again becomes negative. This term is positive, but because of this minus sign, it again becomes negative. Therefore, f dash of x is less than equal to 0 because of this minus sign. This is square since it is always positive, but because of this minus sign, the derivative becomes negative. So here f dash of x less than equal to 0. So here write here minus 3 into x minus 1 square is less than equal to 0. Therefore, f dash of x is less than equal to 0. Therefore, f of x is a decreasing function. म्हणजे काय होईल बाकी टर्मचा स्क्वेअर आहे. स्क्वेअर ऑफ एव्हरी रियल नंबर इज ऑलवेज पॉझिटिव्ह, वी नो दॅट. बट आउटसाइड काय दिलाय, -3 दिलाय. म्हणजे त्या टर्ममुळे आतली टर्म जरी ती पॉझिटिव्ह आली स्क्वेअरची टर्म, बट बिकॉज ऑफ दिस मायनस साइन ते तर काय चेंज होणार नाहीये. म्हणजे त्या मायनस साइनमुळे हा टर्म पॉझिटिव्ह आला तरी ती काय होऊन जाणार आहे, निगेटिव्हच होईल. सिन्स द डेरिव्हेटिव्ह इज ऑलवेज लेस दॅन 0, since the function is decreasing function. Now see the next question. F of x is equal to x minus 1 upon x. F of x is equal to x minus 1 upon x. Differentiate with respect to x. Then derivative f dash of x. Derivative of x is 1 minus derivative of 1 upon x is minus 1 upon square. Since the minus will become plus. 1 plus 1 upon x square. Now look at here. The 1 is positive and here x square. So x square is always positive since square of every term is always positive. X square is always positive. Therefore, the 1 upon x square is always a positive. Since f dash of x greater than equal to 0, therefore the function is increasing function. Therefore, the third function is also an increasing function. Now see the next question. Find the values of x for which the following functions are strictly increasing. That means here we have to given the function which is increasing and we have to find the value of x. Question 2. Find the value of x if the function is increasing. Find x if the function is increasing. That means f of x is equal to 2x cube minus 3x square. 2x cube minus 3x square minus 12x plus 6. So the function is increasing. The given condition is what? Function is increasing. So function is increasing. That means we have to take its derivative and take the derivative is positive because given condition. F dash of x 2 into 3 6x square minus 3 to the 6x minus 12. So from this we take 6 common, x square minus x and minus 2. So here we will get the two factors. Since function is increasing, therefore f dash of x greater than 0. Function increasing है, so its derivative कसा असायला पाहिजे, पॉझिटिव्ह असेल. डेरिव्हेटिव्ह व्हॉट इज द डेरिव्हेटिव्ह, 6 into x square minus x minus 2 which is greater than 0. That means 6 is multiplied, since in this side it become x square minus x minus 2 which is greater than 0. Now we have to factorize it. That means we have to find the two numbers whose product is -2 and addition is minus 1. Since we take these two numbers, that is minus 2 and plus 1. If we take the product, then it is minus 2, and if we take the addition, then it is minus 1. X square minus 2x plus x minus 2 greater than 0. Simply we have to factorize this equation. So from this we take x common, since it is x minus 2, plus from this 1 common, x minus 2 greater than 0, since it is x minus 2 into x plus 1 greater than 0. Now the most important thing in the factorization for increasing or decreasing function. So don't forget this. If there is two factors, say a and b, function is increasing and function is decreasing. And we must know if function is increasing, then f dash of x greater than 0, and for function decreasing, f dash of x is less than 0. And if we have to get two factors of this f dash of x, that is a into b, these are two factors, ab greater than 0 and here ab less than 0. So we will consider two cases, case first and case second. So if product of two factors is positive, then case first is a greater than 0 or b greater than 0. Means first case काय consider करायची, जर increasing असेल तर both are greater than 0 and both are less than 0. Both are positive, both are negative, and which is very important. फंक्शन इंक्रीजिंग असेल आणि दोन फॅक्टर्स मिळत असतील तर केसेस करायचे तुम्हाला, दोन केस, फर्स्ट बोथ आर पॉझिटिव्ह, केस सेकंड बोथ आर निगेटिव्ह. अँड इफ द फंक्शन इज डिक्रीजिंग अँड वी हॅव टू गेट टू फॅक्टर्स, that is ab less than 0, then the case first, if a greater than 0, then b less than 0, and the case second, a less than 0, b greater than 0. If it is increasing, then the both factors are same, either it is positive or it is negative. But if function is decreasing, then first factor is positive, second is negative, and in case second, first is negative, second is positive, which is very important. Now see here we get the two factors, that is x minus 2 and x plus 1 greater than 0. So again here two factors, that is ab greater than 0 and the given function is increasing. So we assume these two cases. So case first, both are greater than 0, and case second, both are less than 0. X minus 2 greater than 0 and x plus 1 greater than 0. That means x greater than 2 and x greater than minus 2. And case second, x minus 2 less than 0 and x plus 1 less than 0. That means x like minus 2 इकडे गेला तर plus 2 होईल and x plus 1 इकडे गेला तर minus 1 होईल. But given function is increasing, function कसं दिले आपल्याला, increasing दिले, म्हणजे मोठी व्हॅल्यू कन्सिडर करायची. मग x greater than 2 and x greater than minus 1. So which is greater? That is x greater than 2. And from case second, x less than 2, x less than minus 1. Since x less than minus 1. So here we consider the value of x, that is x is greater than 2 and the x is less than minus 1 function. Therefore, from case first and second, function is increasing. Therefore, x greater than 2 and x less than minus 1, or interval we write this as a x belongs to 2 comma infinity or x belongs to infinity comma minus 1. These are the two values of x where the function f is an increasing function, which is important thing, that is for increasing, जर function increasing असतील तर both factors are positive, both are negative. If function is decreasing, first positive, second negative, case second. पहिल्या वेळेला घेतलं होतं त्याच्या अगदी व्हाईस वर्सा आपल्याला उलटी केस कन्सिडर करायची. Now see the next question. What is question second here? The function f of x is equal to f of x is equal to 3 plus 3x minus 3x square plus x cube. 3 plus 3x minus 3x square plus x cube. So given function is increasing, so take its derivative and take it is positive since given condition. Derivative of 3 is 0. Derivative of 3x is 3. Derivative of minus 3x square minus 6x plus 3x square. That means it is 3x square minus 6x plus 3. So take 3 common from this. X square minus 2x plus 1. Now again we have to factorize this. First, function is increasing. Since we take derivative positive, therefore f dash of x greater than 0. That is 3 into x square minus 2x plus 1 greater than 0. Therefore x square minus 2x plus 1 greater than 0. 3 से multiply होता है फिर 0. Now again factorize this equation. That means we have to find the product is 1 and addition is minus 2. So take the two numbers. Minus 1, minus 1. Addition is minus 2. And if you take product of minus 1, minus 2, it is plus 1. X square minus x plus 1 greater than 0. From this x common, from this 1. X minus 1. If you take minus 1, then it is x minus 1 greater than 0. Now again see here, function is increasing. So again we have to consider these two cases. X minus 1 into x minus 1 greater than 0. That is only 1 here. Both the factors are same. That means x minus 1 greater than 0. X minus 1 is greater than 0 here. This is what? That is 3 into x minus 1 square, which is greater than 0. That means x greater than plus 1. X is greater than plus 1, or we write it as an r minus 1. म्हणजे फक्त x च्या 1 ह्या व्हॅल्यू साठी आपल्याला फंक्शन काय होतं, इन्क्रीजिंग मिळते. सो r minus 1 ही व्हॅल्यू काय करून घ्यायची, काढून टाकायची. ही व्हॅल्यू सोडून म्हणजे 1 सोडून सगळ्या कोण असतील x च्या व्हॅल्यूज असतील. If our function is increasing function, if x is not equal to 1, then the whole set of real number is the values of this function. For this we satisfies our function. Now you should try to solve the our next question, that is question 3rd. And in question number 3 we have to find the values of x for which the function is strictly decreasing. So we will solve the question number 3 in our next lecture. Thank you.